All right. Thank you, everybody. Thanks for being here. I'm Parecki, and I'm really excited to talk about why we need OAuth. And I do want to, of course, thank the sponsors for the conference for making this all possible. So, as more and more of our digital lives are moving online, the security of the online accounts are, of course, becoming more and more important. And hackers are getting more and more creative and can do many, many interesting things when they find vulnerabilities in applications. And that can be anything from extracting millions of dollars from businesses with ransomware, shutting down critical infrastructure, and even taking over YouTube channels and live streaming cryptocurrency scams. It happens. It is hard to imagine that it used to be the case that the extent of damage that an attacker could cause was just stealing your address book and spamming people. And that is really why, that's what we're here to talk about today is, yes, hacks are bad. Why is that related to OAuth? I'm going to show you how OAuth actually can make your online life a lot more secure and help prevent attacks like these. I'm Parecki. I work at Okta, where I help people understand OAuth, online security, teach people how OAuth works. And I also actually participate in the group that makes OAuth, the spec. That's at the IETF. Most recently, I've been working on the OAuth 2.1 update to try to bring this more into the modern world and make this stuff just a lot easier to understand. So let's jump into OAuth. This is the spec. This is RFC 6749. This is kind of where it all begins. And it turns out specs are actually really not a good way to learn this stuff. They're, of course, important. It's important to have the specs. It's important that we all agree on what goes in them and that they are very well written and carefully written, but they're not tutorials. And while this is OAuth, it turns out there's actually a lot more to it than just RFC 6749. There's dozens and dozens of specs that make up the whole space of OAuth and its related counterparts like JSON Web Tokens, OpenID Connect. There's even multiple working groups in different communities, different organizations that actually all come together and work on the different bits and pieces. So when we talk about OAuth, we're often talking about a lot more than just the one spec that was written very nearly 10 years ago. So you might be familiar with OAuth from the way it gets used in buttons like these, log in with Facebook, log in with Google. Is that OAuth? Well, yes and no, but mostly no. We'll go back a little bit and talk about why OAuth was originally created to show how this is or is not OAuth. So originally, the goal of OAuth was to be able to limit or delegate access to data. Those are very specially chosen words, but basically what this means is when an application would launch, like Yelp. This is a very old example now, but it used to be very common, where an application like Yelp would launch, and the first thing it would do is it would say, let's go see if your friends are already using this application. Well, where are your friends? Before Facebook, it was in your address book, in your email. Who do you email all the time? So the app wants to access your contact list, which is in your email account. The app is then going to ask you to give your password to your email address, to your email account, so that it can go and read the data. This is obviously bad, and thankfully this doesn't happen today really at all, except for in the entire banking system in the US. So there's still some work to do, clearly. But the problem here is that you've given a third party, Yelp or Facebook, the credentials to a different company's account of yours, right? Gmail. So there's a number of reasons that this is problematic. Even though this application is really only needs access to some of the data in your account, for example, the contacts. What you've done here is you've given the app access to all of the data in your account. It can actually access your actual emails and even do things like send email from your account. You've given it all this access, and there's no way to take it back. There's no way to revoke that application's access. Once you've given it your password, anything you can do with your account, so can this other application. So basically what it means is that you've trusted this app entirely to do the right thing and to not do things it shouldn't be doing, which sometimes is mostly fine. Like in the banking example, you generally trust Mint with your banking credentials to not go and do bad things with your bank account. We should, again, be doing better than that in that industry. But back to this consumer example, we're not going to be able to train users to not do this. Like, users wanted the ability to find their friends within the application. So we have to find a way that allows them to do that, to give access to the contacts in their account, while also preventing access to the actual emails. And to do this, we're going to look for a way to give this application something that lets them have access to this data that has limited scope and limited lifetime. And that thing, we don't really have, is there a name for it? Well, that's, I guess, a token, right? We don't really have a good name for it, but that's what the word token comes from. So bring this back into the real world, another analogy of this is like checking into a hotel. When you go to the hotel, you're intending to access some things in the hotel, like the hotel room that you've paid for. You go to the front desk, you check in, you show them your ID and credit card, and they give you back this hotel key. You take the hotel key and you go to the door and you use that to open the door. Notice that in this example, you don't swipe your ID or your credit card on the door of your room. You're presenting a different token to the door in order to access it. And that might give you access to multiple resources in the hotel. Your room, the front door, the elevator, the pool, the gym, different resources that you are authorized to access. And the other reason this is similar to OAuth is that door, in order to know whether it should open when someone swipes a key, it doesn't actually need to know the person behind it. What it needs to know is this card authorized to open this door right now? So the counterexample to this would be like if you went to the hotel and they just gave you a skeleton key that let you open all the doors in the hotel, and they just sort of hoped you only accessed the doors that you were supposed to. So this makes a lot of sense for the third-party app use case. We can clearly see why, with third-party apps like Yelp trying to access Google data, or Last.fm trying to access Spotify data, or Buffer is trying to post to your Twitter account, it's clear that there is a need to not share the password so that we can limit what this application can actually access. So the way this actually works in practice is you're on this application, let's say Facebook, and you've got the sign in with Google button. Instead of Facebook asking for your Google password, it sends you away from Facebook over to Google. That's where you type in your email. That's where you type in your password. You may even do two-factor auth at this stage. And it may also ask you if you are intending to log into Facebook and share certain data. And then it eventually will send you back to Facebook, and Facebook has the things it needs in order to access that data, the right tokens. And it's really this idea of asking the user for permission that was at the core origins of OAuth. We wanted a way to be able to say, hey, you're trying to log in, we think you're trying to log into this application and share this data. Are you actually trying to do that? Do you want to share this data with this application? So this is what it looks like when something is trying to access your Google data. This is Twitter's version of it. Different design, similar concept of, are you actually intending to allow this application to access this information from your Twitter account? Same with GitHub. GitHub has its own version of this. Do you want to allow this application to access your public repositories and your personal information, but notice not your private repositories. Some servers have gone so far as to actually let the user uncheck certain options, where the app may be requesting access to everything, but the user may deny access to certain parts of their account, which is a pretty cool feature. So this is really where it all started. This is where it came from. But what about first-party apps? First-party apps being the case where the application and the data being accessed are the same brand. So the Twitter application on your phone accessing data from the Twitter API. It doesn't really make sense for the first thing to do if you download the Twitter app is to have it ask, is it okay for this app to access your Twitter data? Because of course it is. It is the Twitter app. So for first-party apps, we don't necessarily have this trust issue. So you might be thinking, well, why can't I just put a password dialog into my app then? And how does this turn out on the projector? Yeah, that's what I thought. This is an example of a real application that I found on my phone. This is the login screen to the application. You can barely tell what it is because it's very poorly designed. I don't even remember what app it is because they didn't put their name on the screen. And there is a button above the keyboard that says sign in, but you probably can't read it because the contrast is so low. And I include this as a counterexample or a terrible example of a design because I hear this a lot. People want, the designers of the apps want full control over the login experience. And it's true that when you use OAuth in a mobile app, you can't create this. You cannot make it look exactly like this. So there's the design aspect, and then there's also the user experience aspect. And that's another argument that people often try to make about why they don't want to use OAuth in a mobile app because they want a better user experience. I want to give you some examples of how OAuth is actually a better user experience and better security, again, by providing a counterexample. You've probably found this screen at some point on your computer, the sign into iCloud. You go to iCloud.com, it asks you for your iCloud password. That makes sense. There's nothing wrong here. But think about for a minute, where else have you been asked for your iCloud password? If you have an Apple device, it probably asks you for your iCloud password in many, many different, completely different looking screens. Everything from, well, iCloud.com, store.apple.com, different website. There's also the App Store native app on your desktop, which has a system dialog. And then just to make things a little bit more confusing, there's like the system password that asks for your actual Mac login password. The challenge here, maybe you are all familiar with this and this is not a challenge for you individually, but I would challenge you to describe to somebody else how to tell whether a particular password prompt is real or fake. And trying to do that, go home later and try to write down a list of instructions. How do you describe to somebody how to identify a phishing attack that's asking for your Apple password? It's very difficult. And then do that again for mobile, because it's a whole different list for how to identify a fake password dialog on mobile. This is a real example, again, of, on the left, a real password dialog from the OS asking for your iTunes password. Notice how they also don't even name it consistently. And on the right is a fake dialog created by this game that's going to then steal your iCloud password. So why is this a problem? Well, phishing is a big problem. And phishing is this idea of tricking the user into giving their credentials to an attacker. One example of how to actually pull this off is this pattern. You get an email, someone shared a folder with you from iCloud. Also, side note, this is really what it looks like when you get a folder invite from Apple. Again, poorly designed email, but this is what it looks like when you get an email from Apple. There is exactly one difference on this screen compared to a real email you get from Apple. There's one character that has changed. And if you can spot it, it is kind of small, sorry for the small type, but if you can spot it, then I will give you a sticker later. So you get this email and you're like, okay, that makes sense, someone's sharing a folder, I'll click it. And then the next thing you see is a password dialog to your iCloud account. That makes sense. You're expecting this. You're expecting to log into your iCloud in order to view this folder. So you type in your password, and then you're like, well, I'm fine. I have multi-factor enabled on my account, so I can't get hacked. So the next thing that happens is you get the prompt for the multi-factor credential, which again makes sense because you're expecting it. You get this on all your devices, and you take the code and you type it into the website, and you're logged in and you see the file. Well, what just happened? You actually just fell for a phishing attack because this website was not the real Apple website. It was a fake Apple website that just looked like the identical one. And if you maybe noticed in the address bar the URL was wrong, you may have spotted it, but most people don't. And why didn't the multi-factor stop it? Because you were expecting to have to type it in, so you voluntarily did. Is it really a hack? It's not really a hack. This is why it's such a challenge. So what good is multi-factor then? I'm not saying don't use multi-factor. Absolutely do, all the time, because it is better than not using it. But the type of multi-factor auth that involves copying a code from one place to another, you can be tricked into copying the code from one place to another if you're expecting to have to do that. Those are anything that involves copying a code or just acknowledging a prompt. So SMS, TOTP, the little push notifications you get in apps that say, are you trying to log in? And you click yes. If you think you're trying to log in, then you will do the things needed to make the login happen, and an attacker can then take advantage of that and log in as you instead. The good news is there are some types of multi-factor authentication where this does not work. You can't be tricked into giving it up. And these are the WebAuthn and FIDO world of authenticators. So YubiKeys, Touch ID, Face ID, the platform authenticators that are built into the operating system. The reason that you can't be tricked into giving up those credentials is because it's not just one credential. Every website that you log into effectively sees a different credential from an individual key. So if you have two different websites, apple.com, google.com, and you use the same YubiKey on both, or the same iPhone with Face ID on both, they see different credentials. So if an attacker were to spin up a website at a different domain that they control, like noreply-icloud.com, then even if you did do the challenge of tap the YubiKey, they would get a credential that was completely useless for anything else. They wouldn't be able to replay it at Apple. So that's great. But now we've actually just created a new problem for the companies that actually intentionally operate multiple domains. For example, Google. They have gmail.com, youtube.com, google.com, and I'm sure dozens more. And it would be nice if you could, use one YubiKey or your one iPhone Face ID as your multi-factor auth across all those different websites. But they all have different domains. So you would have to enroll it once for each domain, which is not a good experience. So instead, let's change things up and actually go and set all of your account stuff up at one domain, accounts.google.com. And that's the one place that you would ever type in your password and do your multi-factor auth. That way, there's only one credential. And then we need some way to connect all of these individual properties that Google operates to this accounts.google.com website, which it turns out is exactly what OAuth does. So when you're on Gmail and you click Login, you may notice that Gmail does not ask you for your Google password. Gmail doesn't actually have a login box asking you for your Google password, even though it is a first-party app. Right? Gmail is made by Google. Everybody knows that. When you have a Gmail account, you know it's a Google account you use to log in. So instead what happens is Gmail says, go over there. Go away, go over to accounts.google.com, sign in there. That's where you type in your email. That's where you type in your password. Now you can use a multi-factor method that is strong and can't be phished because you're on the one domain, regardless of the app that you're signing into. And then you get redirected back to Gmail and you're signed in. And the same thing is true when you're signing into youtube.com. You get sent over to accounts.google.com. You log in there, do your good MFA there, and then come back, and now you're signed in. So this is great because another sort of side benefit here is that your teams that are creating these applications like Gmail and YouTube now actually don't need to worry about how to deal with logins. They don't need to worry about how to securely handle passwords. how to do the right incantations to make WebAuthn work. Like, none of that matters anymore to them, because all they do is they just say, oh, someone's trying to sign in, go over there, and then eventually come back and it'll work. Speaking of other things that you need in order to build a successful authentication system, there's a lot more to it than just a password box. What about the whole world of sign up, registration, as well as account recovery? There's actually a lot to it. We'll go through a hypothetical flow chart here of like what you might be sketching out if you're starting to start building this. You know, your app launches and you're like, cool, we got a login. We click the login button. The user is going to be shown a login form, and if they enter the correct password, then they will be logged in. And this is the sort of how you might think of the problem space at first. You're like, this is the happy path. We're going to go, and everything's going to work great on the first try, and cool. Okay, what if they type in the wrong password? Well, then we'll just send them back to the login form and show a little message. That's straightforward enough. What if they forgot their password? Now we need some way to have them reset their password. So we need a password reset form that might ask them for their email or their username or whatever that is. And then you're going to have to go and now send an email to them. So now you have to go wire up some sort of email delivery system, right? Then you're going to include some sort of magic link in that email so that when they click it, they can set a new password, which means when they click that link, they have to go to a web page somewhere that you now need to create. That has to have a form that will let them set their new password. And then you can consider them logged in, or maybe you bounce them back through the login form again, up to you, right? Cool. What about your sign-up flow? Well, when the app launches, you need also to be able to create a new account. So you have to make a registration form. What happens if they've already signed up but they forgot? Maybe you send them through the password reset form. Again, you get to make these decisions. If it is a new account, then maybe you send an email to them, and then they, again, click a link to confirm the email, and then they're signed in. So this is probably the most simple version of what this flowchart actually looks like in practice in these systems. And this is not particularly interesting work to be doing when you're building an app, which is, again, where OAuth can come and solve this for you. When the developers are building the Gmail application, the last thing they want to think about is how users are signing in, because that's not the point of Gmail. The point of Gmail is sending emails, receiving emails, and being good at that. So if you imagine with just the button that says go over there to log in, then Gmail effectively is out of the picture as soon as they click that button, and the rest of that is just done by the OAuth server. So you can kind of treat it as just a black box from the application's point of view. You sent the user away to the OAuth server, stuff happened, and then they came back, and now you got the things you need to consider them signed in. And you make it the OAuth server's problem to deal with all of that complexity. So, back to the original question. Is this OAuth? Kind of yes, because in one sense, it's doing that work of offloading all the complexity of account sign-up and recovery to these third-party services. But, again, back to the original idea, it wasn't really OAuth, because OAuth was always about providing access to data, not necessarily signing into apps. Think back to the hotel key example. The hotel key it's like an OAuth access token. It gives you access to data. It gives you access to resources in the hotel, one or more doors in the hotel. And that door doesn't care about who you are. It doesn't need to know your identity. It just needs to know, is this card authorized to have access to this particular door at this time? So what are these buttons if they're not necessarily OAuth? They are built on OAuth, and they are OAuth plus some custom stuff, usually. And in the consumer space, what happened is this problem of needing to delegate access or limit access to third-party apps started with that access, but then the companies that had these APIs that became popular said, well, people can also use it to sign into other apps, and then built the custom stuff to make it happen. The standardized industry standard way to do that is OpenID Connect, and that's what ends up getting used by a lot more of the enterprise world and business to business and that side of the space of providing the identity information of the user logging in to applications. So when you're looking at OAuth and OpenID Connect, you can think of OAuth as the part that lets you lets the application access data in APIs, and you can think of OpenID Connect as the part that identifies users and talks about signing into applications. So, OAuth is the thing that lets your applications not have to worry about handling passwords, account recoveries. It offloads all that complexity. It lets you use stronger multi-factor auth methods to actually enable much, much better security. And that is really the foundation here. If you're curious, I know we kind of talked about this just at a high level, but if you're curious about learning more, I have a lot more information at these 2 links where you can get a much more deeper dive. Sorry you missed the workshop yesterday where we spent the whole day talking about this stuff in great deal. It was a lot of fun. I know a few of you were there, and I appreciate it. That was a lot of fun. Since we have a couple more minutes, a quick little notes about where this stuff is going in the future. There's a lot of work being done still in OAuth. It's by no means done. It is an actively developed spec. There's a big community behind continuing to develop the specs and improve them. There's a lot of work being done on, I quote unquote, high security OAuth. The idea of taking all the bits and pieces and making them even stronger and looking for more places where there might be problems and trying to patch those up. There's a lot of work being done still for applying it to more concrete verticals, solving problems that only exist in certain spaces. Big areas that those are working in right now are health and finance. So thankfully, there are a lot of banks getting on board with OAuth and developing this, and also using it to solve their more specific problems, like, for example, authorizing a transaction of a certain amount, which is something that is very OAuth-like. Are you actually trying to pay this person $20? Or would you like to let this app transfer up to $1,000 a day? Those kinds of authorization requests. And an active effort that I'm working on right now in the group is OAuth 2.1, where we're trying to basically simplify and consolidate the 10 years of specs that are kind of hard to read right now. So trying to make it a little bit more accessible to people who are new to the space by giving you a new baseline to start from, and then you can go and take a look at the more advanced extensions off of that. So with that, I will leave you there. Thank you all very much, and hope you have a great rest of the conference.